In this lecture segment, we'll look a bit more at elementals and wrappers, and then we'll finish up a look at the grid display code. Now, the wrapper class discussion from the prior segment brings up a general point regarding object-oriented languages. Dealing with elemental types is always an issue in the design of such languages, and there are two major approaches. The first is what we've just seen, the use of wrapper classes as in Java, like integer, for instance, and double and so forth. Now, this incurs the cost of autoboxing, but it lets us declare elemental variables that aren't objects and use them directly for faster computation. Now, the other major approach is to make everything in the language, even something as simple as an integer, into an object. In such a language, int, for instance, would actually declare an object. Now, this unifies all the types as objects and eliminates the need for autoboxing. It also allows neat tricks like numerical objects that have methods. In a language like we're talking about, you might be able to write something like index.squareRoot, calling a method on the int index and then getting its square root. But since every number must be dynamically allocated and dealt with as a full object, this approach is computationally slower than elemental types. The everything as an object design is common in scripting languages like JavaScript or Ruby, where flexibility and expressiveness are higher priority than fast numerical computation. And aside, by the way, for C# programmers, you might say there's a third option, which is to make elementals into objects that aren't dynamically allocated, as in C#. But this is mostly a fancy way of doing standard elemental types. C#, for instance, still needs autoboxing. And then one final note on the wrapper classes. They're a natural spot for constants and static methods that deal with the elemental types that the class wraps. It's easy to see this by looking at the Java docs, so here are two more questions to answer by reading those docs. The first one, what constant holds the maximum value that can be put into a long? Write the code you'd use to assign that maximum value into a long variable. Giving you some time to think about it there. Looking at the docs then for long, which is the wrapper, of course. The class includes static member data for max value and min value, and all the other wrappers do the same thing for their respective types. So if you wanted to assign a maximum value into a long, you write something like, just kind of typing it in here, that. Okay, and then question 2. What if I have a string, call it str, and it contains digits, so it's literally the string 1, 2, 3, 4, and I want an int value that is the numerical equivalent of the string, 1234. Write the assignment to do that. So I want something like int x equals, and then some operation on stir over here. And do this using the wrapper classes. You might find some ways to do it in string class as well, but do it using the wrapper classes. And after some time to think there, the wrapper classes also have static methods for various common operations on the equivalent elemental type, including methods for translating to and from text format. And parse int right here is a good example. The parse int takes a string and returns a elemental int. So what we would write, and let's put this in notes here so you can have it as a record on the lecture. What we would write would be int x equals integer dot parseInt. It is a static method after all, and pass it stir. That'll parse stir into an int. There are a couple of other approaches you might have come across, and that's fine if so. They are perhaps not quite as fast. They do involve several steps, including an unboxing, but if you wanted to do it this way, you could. New integer of str will create an integer object using str as its argument. It'll parse the string, but then you'll have to unbox it to put it into int. And integer.valueOf, another static method, does the same thing, just a different way. So anytime you seek some routine conversion on or limiting value for an elemental, look at the wrapper class first. Now, the remaining code in grid display is yours to figure out. You'll need to do so to work on future projects or LMQs based on code worlds. But there are no further OO concepts illustrated by it. So please read through it on your own now, even if it takes a bit of time, and then answer these questions. So question 3, and again, perhaps after a bit of reading on your part, if need be, what is max label for? The comment will help, of course, but be specific. How is it used? And then a related question, if I want the field size for a format specifier, say in a system out printf call, to be determined by a variable rather than a fixed constant. So if I want to do percent some unknown value d instead of percent 3d, how do I do that? And again, perhaps after you've been thinking for a bit there. First of all, max label, as it says, gives you the size of the largest two-string result, and the reason for that is that we want to be able to make the columns a fixed size, and we need to know the largest necessary column in order to do that. And add displayable, as you can see, updates max label each time, possibly increasing it if the two-string of the next displayable has a length that warrants a higher value there. And then we create a variable field width, as down here, by hand assembling the format string. That'll actually produce something like %4s if max label is 4, and we use it down here when printing out the columns of the grid right there. Okay, and then question 4. If, say, cow is at an XY location 19.5, 25.9, and this is in the transcript as well if you want to look at the numbers, and then assume grid step is 4, at what column and row in the grid is the cow placed? 19.5, 25.9, XY, and grid step is 4. If you've had some time to think about the math there, then if we look up at the logic of compute index here, what we will find is that it would go in column 5, row 6. An x, for instance, of 19.5, which would be the value passed, with a 4 for the step, would give a column number of 19.5 divided by 4, round to 5. And remember, by the way, that x corresponds to columns, right, not to rows. Okay, number 5. What happens if two displayables fall at the same row and column in the grid? And probably after some looking through the update call here, or method, you would reach the conclusion that the last one in the DSP's list sort of wins and replaces any earlier ones at that location. And that's because every time we find a new displayable that is in bounds, we replace whatever was at grid row call with that new displayable's two-string, even wiping out an old one if it's there. And then finally, question number 6. What initial value does each element in a two-dimensional array of strings, like grid, have? And returning from perhaps a short pause there, the initial value of any array in Java, including a two-dimensional one, is null, if it's an array of references, at least, as a string array would be. And you can deduce that by the fact that it evidently expects grid row call to remain null if it was never given any value, because that's what our condition is for putting a period in the grid. All Java arrays are initialized either to 0 or 0.0 or false or null, depending on the array element type. Okay, that wraps up grid display. In the next segment, next several segments, we'll look at the code world's main class.